Hey Calc, we got a lot to talk about this week, but for this video, I'm really just trying to go through some examples with you to help get your 7.5 accomplished. 7.5 is all about using all the strategies we've learned for integration and put them together to solve problems. So we're going to go through some strategy and do some examples together in this video. You can see on the right I have the table of integration formulas there just to remind me of some of the things we might be making use of here. But three major strategies we've used at length in class are here on the left. The first one is simplify. If there's ever a time with an equation that looks like simplification can make things easier for you before you integrate, do it. In this example, I've got trig, and sometimes putting trig back into its roots can help you solve a problem. For example, this one could be written as sines and cosines, right? Because tangent is, go away, sine x over cosine x. Okay, and I'm dividing it by secant squared x or multiplying it by 1 over secant squared x. But that can also be written as cosine squared x over 1. This is the same. These are equal to each other. So if I simplify these two, my integration can cancel a cosine on top and bottom, and I'm left with sine x times cosine x dx. I guess these should be thetas, huh? Technically. All right. So there I've got a real simple problem to solve, right? From there we've done that before. Now, simplifying is one thing, but if you see a substitution, go for it. Jump into that and use it right away. For this problem, for example, the denominator has an x squared in it and the top is an x. That's 1 degree off, and that tells me that substitution might work if I use substitution for the bottom. Because if I take derivative of that, I end up with 2x dx. Now this is nice because the top has an x and a dx. The 2 is that just needs to be adjusted, which we've done plenty of. And now I can make that substitution. Over here, I can keep the 1/2 out to the side. I have 1 over u du because the x squared 1 has now become u. Okay? Then the other 2's have been substituted for. So from there I can solve. That one's real quick and easy, so I'll do that. 1 over u is the natural log of u. But u is equal to x squared minus 1, so I'll put it back in, plus c. Alright, manipulate the integrand. Sometimes it pays just to manipulate. So, this problem doesn't have a solution that's cookie cutter for us. We don't have that in our examples. But one really good thing to do with cosines and sines sometimes is to multiply by a conjugate. This will sometimes give you an identity that you can substitute for. And so this is algebraic manipulation right here. When we do that multiplication, we end up with 1 plus cosine x on top. And the bottom becomes 1. The middle terms cancel. And then you've got 2 cosine x's multiplying. Okay? However, this bottom part, even though it looks more complicated right now, this bottom part can simplify. Or we can use a trig identity. Okay? 1 minus cosine squared x is equal to sine squared x. And so we have 1 plus cosine x over sine squared x. And you go, wait, that doesn't look much better. Hold on, just wait. Okay? If we're going to do more manipulation here, we can have 1 over sine squared x plus the integration of cosine x over sine squared x. And this is where knowing our identities and knowing our integration tricks is really handy. cosecant squared x. If you go back up here, cosecant squared x is on there somewhere. There it is. Cosecant squared x minus negative cosine or cotangent x. So this just becomes a negative cotangent x, and that's done. What can we do over here? Well, good old u substitution, really. U is equal to sine, no, let's not make it squared. Sine x, because du is equal to cosine x dx. Okay? I haven't been putting the dx's in here, but they're there. So, substitution will work here. I will end up with a 1 over u squared du. Okay? Now, the integration of 1 over u squared du is, well, that's u to a negative 2, isn't it? So I'm going to have to go up a value, which is a negative 1. Okay? So it ends up being a u to a negative 1 plus c. Okay? So this is going to be a minus u to a negative 1 is 1 over u. So minus 1 over, what was my u equal to? Sine x. 1 over sine x plus c. And there you go. All right, manipulation, a little more complex problem. But we have a couple more here that I want to do. So these are just examples in the book. They don't tell you what kind of skill to use. But looking at this problem right here, okay, what in here makes sense to me? Normally I want to look for a substitution or a simplification first. I could try multiplying the square root out, but the x out in front is kind of problematic. Okay, what I do know is that the derivative of the natural log of x is equal to 1 over x. And I have a 1 over x right here. 1 over x. 1 over x dx. That means I want to try u substitution. I'm going to use my u substitution for the natural log of x. Du is equal to 1 over x dx. And I have 1 over x dx right here to substitute for. So what does this become? Well, the x dx becomes du. And 1 over the square root of natural log of x becomes 1 over the square root of u. And we've done that integration before. Okay, that's really u to the negative 1/2 du. So we go up one value, which is 1/2, and then divide by 1/2. So that becomes 2u to the 1/2 plus c. And let's substitute back in 2 square root of natural log of x plus c. All right, final one. In this problem, we've got a mess. And so, when you've got a mess, maybe a conjugate will work. Well, I know a conjugate will work. Sometimes you're going to have to play with what you're doing a lot to figure out what to do. But in this case, I don't want a conjugate necessarily. I want to multiply by the top, 1 minus x. Because if I can get the square root off the top, I can break this whole thing apart into 2 integrations, and that might simplify things for me. So let's see what happens when I do that. The top will become 1 plus x. The bottom, not so pretty. I've got the square root of these two multiplied together. So there's a 1 there, but the back half is a minus x squared. Now the reason I did that is because perhaps splitting it apart will help me. So let me try. I'll have 1 over the square root of 1 minus x squared plus x over the square root of 1 minus x squared. This is all the x. Now we can separate it. Okay, this is good news. If you know your integrations, 1 over the square root of 1 minus x squared. See it on there? Trust me on this one. Maybe I'm not seeing it, but we've done it before. Is the inverse sine. Okay, so this actually becomes sine -1 x. That's the integration of that. Now we just have to figure out the second part right here. Okay, the integration of x over the square root of 1 minus x squared. No problem. The bottom has a power of 2, the top has a power of 1, which means that u substitution might work here pretty well. If I set my u substitution up to be 1 minus x squared, my du will be 2x dx. Okay, 1/2 du is equal to x dx, and I have an x dx in there. Okay, so this will be the integration of 1 over the square root of u, which we've done before already in this lesson, right? So let's do that to find out the result. Okay, so the sine of a -1 or inverse x plus the integration of this. Okay, we said that's a -1/2, so it becomes a negative. Comes a negative. Lost my train of thought here, folks. U to the -1/2. Integrated is u to the 1/2, 2. That's what. There we go. Minus 2 to the square root of. What is that? Square root of, oops, I know what I'm doing wrong. Square root of 1 minus x squared. There we go. Plus c. And there's my second half. Done. Sorry, almost made it through everything without drawing a blank, but that should be the answer to your second problem. So there are a bunch of examples for you to fast forward to, use again. If you see anything that I missed or have additional questions, please make use of our Teams page for that so we can get through anything else. If you want a conference before Wednesday, try and make a request on our pages too, and we'll try and get to them. Okay. I will probably just be looking for students who are asking for questions, and then on Tuesday I can maybe make a video of some of the additional help if you guys get to me in time. So start working on your lesson so we can get to those questions. Okay? All right.